What's up, guys? Welcome back to another video. And in this video, I'll be walking through the 2024 AP Calculus BC FRQ. And I have not touched AP Calculus BC for around 3 years now. And I'm doing this completely blind, so with no prior preparation. So we'll see how this goes. All right, let's get started. The problem says the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius. For 0 is less than or equal to t is less than or equal to 12. Selected values of c of t are given in the table shown. So we have this temperature, this function of the temperature given time. And the temperature is decreasing as time goes on, which makes sense because coffee cools down over time. So part A says to approximate C prime of 5 using the average rate of the average rate of change of C over interval 3 is less than 7. Show the work that leads to your answer and you include units of measure. Okay. So remember, a derivative is essentially an instantaneous slope. So a derivative is just the rate of change of a function, or the function that represents the rate of change. So if we want to approximate c prime of 5, that would mean that we would essentially use the slope function. And the slope function, remember, m equals y2 minus y1 over x2 minus x1. This is the slope function. So if you have c prime of 5, we're going to approximate that. We just take the average rate of change from when t equals 3 to t equals 7. So this means that t of 5, this is part A, by the way. So t of 5, c of 5, right? So c prime of 5 equals 69 minus 85 over 7 minus 3. And we can plug this into the calculator or we can solve it by hand. We'll solve it by hand for now. And this is equivalent to negative 16 over 4, which equals negative 4. And they want to show the units of measure. So this is just Celsius over minutes. So negative 4 degrees Celsius over minutes, or minute, 1 minute. So the part A answer is C prime of 5 is equal to negative 4 degrees Celsius per minute. Okay, let's move on to the next part. I don't know how to scroll this thing down. Not really working. There we go. Say scroll down. Okay. So part A done. Let's go to part B now. Part B says to use a left Riemann sum with the 3 sub-intervals indicated by the data table to approximate the value of integral of t equals 0 to 12 of ct of d c of t dt. Okay, so we're going to use the left Riemann sum with the 3 sub-intervals indicated. So how do you use a left Riemann sum? Well, obviously, a left Riemann sum means we're using the left value. And the idea behind Riemann sums is that you're essentially, because an integral is basically the area under the curve, we want to approximate that area under the curve using rectangles. And we want to take the left value for each interval. So if you look from the value from 0 to 3, when t equals 0 to 3, and then c of t is 185, well, that is almost the same thing as if it's from 0 to 3, c of t is always going to be 100. It's almost the same thing. So we're going to approximate that using the value on the left. Okay, so for part B, let me switch my computer for 1 second to make it easier for you guys. All right, part B. So part B. Okay, so we have 100 times 3 minus 0 plus, right? So this is the first rectangle. 85 times 7 minus 3 plus 69 times 12 minus 7. And we can evaluate this. This equals, right? This equals 300 plus 85 times 4 is, it would be 340, I believe, plus 69 times 5, which is 45, 3, so 345. And this equals 985. So this would be the approximate value. And we'll interpret the meaning of this integral, which is 1/12 of the integral from 0 to 12 of c of t dt. So this is just essentially what we're doing here is we are taking the total amount, right? So we're taking the temperature, right? Like summing over all like the infinitesimally small rectangles for the temperature. So like from like 0 to 0.1, we have this temperature. From 0.1 to 0.2, we have this temperature, and so on and so forth. And then we take 1/12 times that value. So that's saying the average temperature rate, right? So this would be saying the average temperature. So 1/12 times the integral from 0 to 12 of c of t dt would be the average temperature of the coffee, which makes complete sense. So 1/12 times integral from 0 to 12 c of t dt represents the average temperature of the what? Of the coffee in degrees Celsius. Okay, that's cool. Let's write the N more neatly. In degrees Celsius. All right, that's good. Part B dot. So we have part A, part B dot, now part C. For 12 is less than or equal to T, less than or equal to 20, the rate of change in the temperature of the coffee is modeled by C prime of T is this function, where C prime of T is measured in degrees Celsius per minute. Find the temperature of the coffee at time T equals 20. Show the setup for calculations. Okay. So we have the rate of change of temperature of the coffee for when T equals 12 to 20. We want to find the temperature of the coffee at time 20. Okay. So basically, if we integrate, right? If we integrate this function, c prime of t, that is basically c of t. And then specifically from t equals 12 to 20, it gives us a difference between when the temperature of the coffee at 20 minutes minus the temperature of the coffee at 12 minutes. So we can have a difference there. So write that out. So the integral, right? The integral from 12 to 20 of c prime of t is equal to c of 20 minus c of 12. This is part C, by the way. Okay. And we can find this value of the integral from 12 to 20 of c prime of t. That's helpful. Then we know c of 12 because we're given that value, which is 55. And we can find c of 20 from that, which is what the question is asking. So now we need to just evaluate c prime of t. So it's negative 24.55 times e to the 0.01 t over t. So integral of 24.55 times e to the negative 0.01 t over t, I believe, is the right function. Let's see. Nope, it is not negative right there. Rather, how to get the eraser to pop up? Why is the eraser not popping up? Strange. Now the whiteboard went back. Sorry, guys, we have a bit of technical difficulties here. The eraser is not popping up for some reason. Okay. Very strange. Okay. I'm not sure what is going on right now with the setup, but hopefully we can get this to work. Very strange. Okay. Oh, anyways, let's make this a plus and make this a negative. Okay. So we have this function, right? And the integral of this is equal to what? This is a little tricky. So, this is actually quite tricky question. Not sure exactly what the integral is, but we can use a calculator for this. Figure it out. I think the best way to proceed is use a calculator for this. So we're gonna use 12 and 20. Because I don't know the integral on the top off the top of my head. So let's use a calculator for this trick. And I'll grab my calculator really quickly. All right, I'm back with my calculator now. And we're gonna evaluate this integral. I kind of forgot how to use this already, but we'll figure it out. Oops, I think I forgot how to use my calculator properly. Mm, mm. This is very strange. I might be getting stuck a little bit right now. Ah, I found the right thing. Okay, on my calculator. Believe you put alpha window. Yes, you put alpha window 4 to find the right integral function. So you put 12, 20, and then the function negative 24.55 times e to the power of 0.01 times x. T and x don't matter, either is the same. And then we have to divide times 1 over x dx and evaluate this. And we do get a value. We get negative 14 point around 671. So, and we know C of 12 is what again? C of 12 is 55. So C of 12 is just 55. So we can just add C of 12 to this value, and we get 55 plus this answer, which is, so C of 20 is approximately 40.329. And we have solved part C of this question. Now for part D. For the model to find a part C, it can be shown that C prime prime equals this. For 12, 20, determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. Give an answer, reason for your answer. Okay. So remember, whether the temperature of the coffee is changing at a decreasing or increasing rate is dependent on the second derivative of the function. And if the rate of change, right? If the rate of change is increasing, and I think this is actually talking about rate of change as in the absolute value of the rate of change. So like if the derivative was like decreasing, right? If the derivative was decreasing, like going from the slope was going from -5 to -6, -7, that would be a negative. That would be negative second derivative because the slope is decreasing. So if the temperature of the coffee is changing at a increasing rate, that means like the derivative of the slope is positive. Yeah. Okay. So I've said that a lot of stuff now. So basically, if you look at this function right here, notice if t is from 12 to 20, 100 minus t would be positive. E to some value would always be positive. And 0.2455 is constant, is positive. T squared is also positive because 12 to 20 is positive. So the double derivative of C of t is always going to be a positive value. That means that the temperature of coffee is changing at an increasing rate. So part D. Part D. The temperature of the coffee is changing at a increasing rate because the second derivative of the function is always positive. From 12 less than t less than 20. All right. We have finished the first part or the first question of the 2024 AP Calculus BC FRQ. Now it's time to check your answers. Let us check our answers. All right. Hmm. Okay. Time to check our answers now. Scoring 9 lines. All right. Okay. So the first question, part A. Question A was 9 points. And it was -4 degrees Celsius per minute. So we have 1 point for estimating with supporting work and 1 point for units. Do we have that? Let's check. We have the division, we have the units. Yes, 2 points. That's good. Part B. Form of last Riemann sum, estimate interpretation. Let's see. Form of left Riemann sum. Yes, we have that. We have that. Let's see here. Interpretation is average temperature from the interval. That is right. Part C, to score it, part C, with the integral, we have 40.329. We got 40.329. Yay. Use initial condition. We do use initial condition. Integral, yes, we got the integral. So I think I got all 3 points for that too. Part 4, part D, I just said you 1 point answer with reason. Because it's positive, it's increasing the interval. That's right. Then we got the answer as well. So overall, I got 9 out of 9 points on this FRQ. And despite not doing AP Calculus BC for over 3 years, I guess I still remember most of the stuff, which is good. So I hope to see you guys next time, and I hope to see you guys again in the future.